Hello everyone. I hope that all of you are well and good. Let's start with your chapter Combustions and Flame. First I will show you video related to your topics and I explain also, and you have to understand the meanings, and after that there will be question answer sessions. Okay, so let's see. Please everyone listen carefully and try to understand.
Combustion. When we light a candle or burn wood, we see flames. These flames are formed as the result of a chemical reaction known as combustion. Combustion can be defined as the burning of a substance in order to produce heat or light.
So basically, combustion is one type of chemical reactions, and here you can see this is called combustion, and combustion substance basically combusted in presence of air. So let's see.
Can further describe the process as a chemical change during which an element or a compound reacts with oxygen and produces carbon dioxide and water vapor.
So what are the things basically produced here? The most important thing, in presence of oxygen, combustion substance will burn and it will produce heat as well as light and carbon dioxide and water also. So let's see.
Occurs in a chemical reaction during combustion. For this, we'll take a look at methane gas, a hydrocarbon composed of carbon and hydrogen atoms. Methane is used as a fuel in gas burning.
So methane basically nothing but a fuel, and here you can see in this picture that in methane how many carbons present. Basically here you can see only one carbons present, right? And how many hydrogens present? 4 hydrogen. That means methane is nothing but a hydrocarbon where carbon as well as hydrogens basically present. Is it clear, all of you?
Yes, sir.
Very good. Very good.
Burners. When the burner is ignited, the gas will undergo combustion and glow with a blue-colored flame. During combustion, the methane will react with oxygen in the air to produce carbon dioxide and water in the form of vapor.
In air, there will be oxygen gas, right? And methanes, when burned in presence of oxygen, methane will break down and carbons react with oxygen. It will form carbon dioxide. Here you can see. So you know carbon dioxide basically is CO2. That means one carbon will be there and 2 oxygen will be there. So here you can see this is carbon and 2 oxygen. This is one oxygen, red color is mentioned here, and this is another oxygen, and this one is carbon. So it's carbon dioxide and it's carbon dioxide structure. Now here you can see oxygens attached with 2 hydrogen, and it's basically form water, right? So let's see. And this is the reactions where CH4, that means methane, react with 2 mole of oxygen, that is 2O2, and it will form CO2, that means carbon dioxide, as well as 2H2O. Clear?
For combustion reactions to occur,
and this is
oxygen
candle, right?
is an essential part of the process. With a very simple experiment, we can prove that oxygen is essential for combustion. We'll light a candle, and once it's burning well, cover it with a beaker. After a few minutes, the flame will slowly grow smaller and eventually go out. Underneath the beaker, the candle burnt until all of the oxygen was used up. Once oxygen was gone, combustion could no longer occur. For any substance to undergo combustion, it must be heated to a certain temperature. The minimum temperature at which a substance will catch fire and burn is known as its ignition temperature.
So here is new term, ignition temperature, and it is nothing but the lowest temperature at which a substance catch fire. Every substance have their minimum temperature, and different substance have different ignition temperature value.
A matchstick is struck against a rough surface on the matchbox because the friction raises the heat to the ignition temperature required for the head of the match to catch fire. Paper has a low ignition temperature and will catch fire more easily than wood, which has a higher ignition temperature and will take some time before it begins burning. Summary: combustion is the burning of a substance to produce heat or light. Combustion is a chemical change during which a substance will react with oxygen and produce carbon dioxide and water vapor. Oxygen is essential for combustion. Minimum temperature at which a substance will undergo combustion is called its ignition temperature.
So here you can see, all of you, that few things, heat and lights basically produced, and carbon dioxide and water vapors also produced in presence of oxygen when any combustible substance will burn, and it's nothing but one kind of chemical change, one kind of chemical reactions. Okay, and oxygens obviously very essential for combustions. Without oxygen it will be impossible. And ignition temperature. I hope all of you understand. Is it?
Yes, sir.
Yes.
Yes, sir.
This is overview. Here you can see experiment and oxygens and what is produced, basically carbon dioxide and vapor. It's basically a chart, nothing else. So here you can see different substeps, ignition temperature will be different. Here you can see for paper it's low ignition temperature, but in case of wood high ignition temperature. Okay, so now another thing, few things mentioned here, all are combustible substance. So first you have to consider which one is lower combustible ignition temperature value. Low to high you have to arrange. So first tell me which one will be?
Paper.
Yes, it will be paper. Then next,
Excellent.
can anyone say?
Plastic.
Very good. Then
Excellent.
Cotton cloth.
no, it's not water cotton cloth. It will be wood.
Excellent.
Then next, anyone?
Cotton cloth.
Exactly. Very good.
Excellent.
Then finally, metal.
Excellent.
Very good. Now next one. Few things mentioned here. The definitions. That combustion is the burning of substance in order to produce heat and light. Please remember this thing. This is ignition temperature. Paper is mentioned here. And ignition temperature is the minimum temperature at which a substance will catch fire, or you can say burn. And it's needed, okay? Without ignition temperature, if you supply temperature and it will less than ignition temperature, then what happens? Can anyone say? Anyone? Mania, please tell me. It will burn or not?
It will burn.
No. Just it will be reversed. Anyway, now methane is basically used as a fuel and the state of methane is basically gas, okay, and it's one type of hydrocarbon where carbon and hydrogen is basically present. So here you can see this is one container, and methane gas is basically present. And this is another video. Please try to understand this thing also.
Types of combustion. Combustion is the burning of any substance in air. When something combusts or burns, it will produce both light and heat. For combustion to occur, oxygen is required. A candle will burn in the open air. But when we invert a glass over the burning candle, it will burn only as long as the oxygen is available inside the glass.
So here you can see these are oxygen, right? These are oxygen presence in air, and this is one container actually. So these are oxygens basically presence in inside, okay, and due to this kind of oxygen's presence in inside, it will burn for few minutes. So let's see.
Because the glass will cut off any outside oxygen, the candle will go out after a few minutes. Combustion can be categorized as one of the three types: rapid, spontaneous, or explosive.
So these are the three types of combustion reactions, or you can say type of combustions basically. One is called rapid, spontaneous, and explosive. See.
Rapid combustion is the rapid burning of any substance, and with this, the production of heat and light. Rapid combustion requires an external ignition. When we strike a match, it will burn, producing heat and light. When we ignite a Bunsen burner with a matchstick.
So what is it? Can anyone say the name of this one? What is this one? Can anyone say? This is Bunsen burner, okay?
The gas will burn and produce a high amount of energy in the form of heat. The burning of a candle and liquefied petroleum gas, abbreviated as LPG, in a gas stove are other examples of rapid combustion. Spontaneous combustion occurs
when this is another one
burns by itself without any external source of ignition.
So for first case, you need external source or external heat or temperature basically, but in spontaneous case, it's not needed actually. And this is white phosphorus.
Phosphorus is left on a plate at room temperature. It will spontaneously catch fire. Many inorganic materials such as hay, cotton, and coal can burn due to spontaneous.
So here you can see all are basically inorganic compounds.
Combustion. Explosive combustion, such as what occurs when firecrackers and bombs explode, is a rapid combustion accompanied by large amounts of heat, light, and sound. Summary. Combustion is the burning of any substance in the air. Rapid combustion is the rapid burning of any substance and will produce heat and light. Spontaneous combustion occurs when a substance burns by itself without any external source of ignition. Explosive combustion is a rapid combustion accompanied with large amounts of heat.
Now here you can see the basic difference between rapid combustion and explosive. Explosive is the part of rapid combustion, but difference is it's produced large amount of heat, light, as well as another new term here, sound also. In case of explosive combustion, it's also produced sound, but in rapid, it's only produced heat and light. And this is another one, spontaneous. So spontaneous, in this case, basically you don't have to apply any external source or external heat. Is it clear, all of you?
Sir.
Yes, sir.
Okay.
Light and sound.
So few definition is here. Here you can see. This is the example of rapid combustion, spontaneous this one, and basically spontaneous case, white phosphorus is an example of spontaneous combustion, and this one ignition temperature is very important. Now please tell me, these are example of different kind of combustions. So first tell me what will be rapid combustions. Nania, please tell me.
Burner.
Okay, and another one.
Excellent.
Candle.
Very good.
Excellent.
Then spontaneous.
Sir, coal.
Okay, coal.
Excellent.
And another one.
Sir, cotton.
Very good.
Excellent.
And these are explosive.
Excellent. Try again. Excellent.
Please remember these things. This is overview. The type of combustions. All three types are mentioned here, and there are few properties also mentioned here. And this is very important. Required oxygen. Now it's question answer session. Please everyone try to answer this one. In what form combustions produce energy? Can anyone say?
Sir, heating.
Sir, D.
D. Water.
Yes,
Energy.
Sir,
It's not
heat.
energy.
Sir, heat.
Sir, A.
A. And another one. Is it only A or something
Sir,
else?
light.
Yes,
Sir, light.
very good. So it will be heat and light. Very good. Now next. Can anyone say? Try.
Sir, A.
Okay. Anyone other?
Sir, A.
Let's check. Is it right or not? No. Now you have three options. Tell me.
Sir, B.
Sir, C. Sir, C.
Who's saying C?
Sir, C.
Sir, me. Sir, C.
Sir, C. Sir, I'm saying C.
Yes, it will be C. Very good, Vedant. And also, I think Lisa. Now next, this one. When basically flame formed? Is it slow process or speedy
Sir,
type?
speed.
Yes?
Sir, B.
Can anyone say other? So let's check, is it true or false? Yes. Now next one. 4. What is the supporter of combustion? When wood is burned, Now I think all of you know which one will be the answer. Tell me first. All of you know this.
Sir, A.
Yeah. Supporter
Sir,
of combustion.
oxygen.
Sir, oxygen.
Yes, it will be oxygen. Very good. Next one. This one. Try. Tell me. Tell me. What are the products of complete combustions of substance? Is it carbon monoxide, carbon dioxide, water, carbon
B.
monoxide and water?
B.
Sir, B.
Yes, very good.
B.
It will be B. Carbon dioxide and water. Now next one. Fuels, charcoal, petrol and LPG.
Sir, fuel.
Okay, so let's check is it right or not.
Sir, fuel.
Yes. Very good. Now next one.
Sir, paper.
Can anyone other?
Paper.
Very good.
The paper.
Yes, very good. So what you have to consider? Only ignition temperature. Lower ignition temperature you have to consider for this case. Now this one, question number 9. For a spontaneous combustion to take place, 4 option is mentioned here. Which one will be the right answer? Please tell me. You know this
Sir,
thing.
C.
Sir, C.
How many of you agree with Vedant and Lisa? I think option C. Mania,
Yes, sir.
you agree with them?
Yes, sir.
Okay. Very good. Now this one.
Sir, B.
B. Lisa is saying B. Anyone?
Sir, B.
Now it falls below its ignition temperature.
Sir, A. Sir, A.
Yes, very
Sir,
good.
D.
It will be
Sir,
A.
A.
Yes. Very good. Now next one. Gas change.
Sir, A.
Sir, A.
Yes, very good. It's chemical change. Very good. And basically it's from oxide. That means carbon dioxide and water. When there will be oxygen, it's called oxide. Anyway. Now the next one.
Sir, coal.
C.
C. All of you agree with Vedant? Is it C?
Sir, B.
No, sir, A. B.
Sir,
B.
B.
Yes, it will be B. Diamond. Very good. Now next one.
Sir, A. B.
Sir, C.
C
Sir,
and
B.
B.
Sir, C.
C. Sir, C.
All of you agree with C?
Yes, sir.
Vedant and what about Mania, is it C or B?
Sir, rapid combustion to B.
Okay, so let's check C or B. I select C. So which one? Spontaneous. Now next one.
Sir, C.
C. Everyone C?
Yes, sir.
Yes. Now next one. Very good. This one, tell me.
Sir, A.
No, it's produced actually. Carbon dioxide produced. It will be hydrogen. Okay. It will be hydrogen. Now next one.
Sir, C.
And
C.
what about option A and B? What are the conditions basically? Obviously substance is required. Obviously supporter of combustion is also required. Yes, it will be all of the above. Very good. Now next one. What is global warming? You all know. I know that. So tell me which one will be the right answer here. 4 option is given.
Sir, A.
How many of you? A is right or not? Anyone?
Sir, D.
Who is saying B? Lisa or Mania?
Sir, Manya.
Okay. What about Vedant? Vedant?
Sir, sir, C.
C.
No, sir. Sir, A.
Yes, it will be A. It's increase in temperature of atmosphere of the Earth, not the land surface of Earth. So it will be A. Clear?
Yes, sir.
Very good. Now next one. I think it's yes,
Sir,
yes, tell me.
D. Sir, D.
B. No, actually it will be exothermic. It will be exothermic reaction basically. Please everyone note down this one. This is very important question. What kind of reactions basically this one? Please note down. This is exothermic reaction. Done everyone?
No, sir.
Yes, sir.
Okay, good. Now this is another one. Please tell me. First tell me.
Sir, D.
D.
Sir.
Yes. And what about Vedant and Mania?
Sir, D.
Okay.
Sir, ignition to B.
Yes. Good. Now the next one. Same as previous one also, like diamond.
Sir, C.
Yes, very good, Lisa. It will be C. Now this one.
Sir, B.
Vedant, tell
Sir,
me.
B.
All of you.
Sir, B.
Yes, it will be B. This is another one. Question number 22. Which of the following is an ideal fuel? You have to say coal, LPG, and petroleum. And another one is none of the above. Which one?
Sir,
Sir, D.
Sir, C. C.
No, it will be none of the above.
D.
Yes, it will be
Sir.
D. This is another one.
Sir, B. Sir, B.
Sir, B.
Yes. Good. Very good. Which one will be the right answer here?
Sir, C.
C. And anyone? Is it C or something else?
C.
Okay, let's check. Is it C or not? No. Then
Sir, B. Sir, B.
no, it will be all the above. Because basically in coal there will be sulfur, there will be nitrogen, there will be carbon. It's a mixed actually, not a pure coal. So there will be so many others, metal, non-metals. Basically non-metals are here, all sulfur, nitrogens and carbon, and it form all sulfur oxides, nitrogen oxide, carbon oxide. Basically carbon oxide means carbon dioxide. So you have to say all the above. Now next you have to answer this one.
C. Ma, A. Sir, A.
Sir, A.
Okay, let's check. Yes. Now this one, full form. You know, all of you know. What is the full form of LPG? Yes?
Sir, C. Sir, C. Sir, B.
So it will be B, liquefied petroleum. Yes. Now this one, what is ignition temperature? You all know the definition.
Sir, D.
Sir, B.
Yes. Now next one. Supporter, non-supporter.
A.
Yes?
Sir, A.
No? Can anyone say? Non-supporter. Not supporter. If it will be supporter, then you have to say oxygen. But basically non-supporter. Anyway, which of the following statement is not true? You have to say. The flame can be seen over burning solid and liquids. Type of flame depend upon the amount of oxygens available. Invisible zone of flame is the least hot zone, and blue zone indicates complete combustion of fuel. Now which one? Tell me.
Sir, A.
All of you A. Anyone?
Sir, C.
Sir, A.
Sir, A.
What about Mania?
Sir,
Is it A, C or something else? So I select C and let's check. C is right, not A. Lisa, is it clear? Because
Yes, sir.
solid and liquid as well as gas all will burn in presence of oxygen. And blue zone, when there will be blue zone, it's basically indicate complete combustion of any fuel. And obviously the amount of oxygens always affect on the type of flame. So color of flame will change and it's depend upon the amount of oxygens basically available. Is it clear, all of you?
Yes, sir.
Okay, very good. Now this one. You have to say disadvantage of incomplete combustions is referred to. First option, unburned, carbon gets released, air get polluted.
Sir,
Or-
C.
Yes.
Sir, C.
Okay, all the above. 4 options. What about Vedant? Is it C?
C.
So let's check, is it C or it's D? It will be wrong.
Sir, D.
Yes, it will be all the above. Because all are right, basically A, B, C, all are right. So you have to say all the above. Now the next one, and this is last one. Please tell me. Hurry up. What kind of reactions is this one?
Sir, C.
Substitution. Everyone agree with Lisa? With saying D? Mania, right?
Yes, sir.
Okay, what about Vedant? Is it D or something else?
D.
It's right. Basically, combustion is one type of oxidation reaction, or it's one type of chemical reactions. And what kind of chemical reactions is this one? It's basically oxidation reaction. It's oxidized. Anyway, thank you everyone.
Thank you, sir.